We've been told to solve the following logarithmic equation, that is log 7y minus 1 to base 2 to be equals to 3 plus log y minus 1 to base 2. So step 1, as usual, you must have the same base, isn't it? You must have the same base. So same base, it means we introduce log 2 to base 2, isn't it? So we now have log 7y minus 1 to base 2 to be equals to 3, then we introduce log 2 to base 2. And log of a number to the same base is 1, isn't it? Then plus log y minus 1 to base 2. So we now have the same base in each and every term, isn't it? So after that you get rid of the coefficient, isn't it? So there's no coefficient here, this 3 becomes the power, isn't it? So what do we have? We have log 2 base 2 of 7y minus 1 is equals to log 2 cubed to base 2 plus log 2 base 2 of y minus 1, isn't it? So we ensure each and every side of the equation has exactly one term, isn't it? So this side is already one term. We have log 2 base 2 of 7y minus 1, then you factorize out, isn't it? So here we'll have log 2 base 2, 2 cubed is 8, isn't it? So addition goes to multiplication if you factorize the log outside, isn't it? So 2 cubed is 8, so we are going to have 8 times y minus 1, isn't it? So that when you take the log back inside, this multiplication goes back to addition, isn't it? Good. So it is base times base. If you take it back, you go back to the original problem. So at this level, this is a single term, this is a single term, isn't it? So we can now ignore logs after you've ensured it is a single term. You cannot ignore logs when it is not a single term on either side of the equation, meaning you cannot ignore log here because it is not a single term. You have to use the laws of logarithm, isn't it? Are we together? Are we together there? You cannot come here and start saying that you ignore the log. No, it cannot work. Because you have to apply the laws of logarithm to make it one thing, isn't it? So this is like you introduce log on either side of the equation, isn't it? Good. So after ignoring log on either side of the equation like that, what do you remain with? 7y minus 1 to be equivalent to 8y. You take 8 inside 8 times y is 8y minus 8 times 1 is 8 is the common factor, isn't it? So from there you collect the like terms. This is the same as 8y minus 7y negative 8, that is 8 minus 1 is 8y minus 7y. So you end up with y to be equals to 1. If you bring 7y this side, if you bring negative 8 this side, it becomes positive 8, isn't it? Are we together? It should be, 8 minus 1 is 7, isn't it? So we have 8 minus 1 is 7, very good. That is what you expect in that given problem.